Okay. Hi, everyone. Um, Good afternoon and welcome to this talk. Um, I'm here to talk about the reality of maintaining and managing open source software 5 years in. Um, the cost of software is divided into three parts. There's creation, there's maintenance, and then there's distribution. Now, usually you would think that the technical bits would be the most difficult parts, but after 5 years of distributing and maintaining open source software with, with my team, we found that the creation and the technical part is the least to worry about. The The actual challenge is in distributing and maintaining the software after you've gotten it to a point where it seems like it's stable. And that's what I'll be talking about in this talk. I'll be sharing how my team has managed to navigate some challenges that we've come across in these 5 years and a couple of things we've learned along the way. And if at the end of this talk you're planning to start like an open source project or you maintain an open source project, my hope is that you get some ideas on how to tackle some challenges from how we've been able to tackle them. Oh, okay, did that. A little bit of introduction about myself. My name is Linda Ikechukwu. I currently live in Lagos, Nigeria, and this is my first time in Copenhagen. So if you live here after my talk, I would really love to know what's your favorite thing to do here. So I find some exciting things to do while I'm here before I leave on Monday. I'm a software engineer and a developer advocate for a US-based startup called Smallstep Labs. And at Smallstep Labs, we build tools that help companies identify company-owned devices with ease. And that means that companies can ensure that things like their Wi-Fi network, ZTNA, VPN, and all of that are only accessible through company managed devices. And by binding access to sensitive resources to hardware, that attack vector of things like credential thefts, man-in-the-middle attack, and impersonation attacks are thwarted. But at the core of our commercial products are two open source projects, Step CA and Step CLI. And we also recently adopted maintenance of the GoSkep library, but I wouldn't be focusing much on that because we just took over ownership or took over maintenance like last month. So a bit of context on these two projects. StepCA is a private certificate authority and Acme server for internal networks. So that means that you can use StepCA within your infrastructure to set up a two-tiered PKI or use it as an online intermediate CA for an existing root CA. You can also use StepCA to issue HTTPS server and client certificates that work in browsers, and you can use it to issue TLS certificates for VMs, Kubernetes pod, database connections, basically anything that has to do with certificates. And then the sister component, which is Step CLI, is a general purpose CLI tool for cryptographic operations. So that means that you can use it to administer an Acme server, anyone, maybe the Step CA, or any other Acme server. And you can also use it to validate certificate deployment and renewal status. You can use it to create key pairs. You can use it to create, revoke, validate, link, and install S509 certificates on your device or like on a remote server. And so much more. You can use it to verify OICD identity tokens and a lot. Yeah. And generate and file, check file hashes. So basically everything, cryptographic operations, you can use Step CLI for that as a standalone or to administer Acme servers. And this is just the sample code that, sorry, where's this here? So this is a sample code of what you can do with Step CA and Step CLI using Step CLI to check the validity of an OICD token. And let's look at our numbers. We launched this project 5 years ago, and in 5 years, it's a very niche project. So we've had 11 K-stars on both projects, 800 forks, and a couple of, about 1,500 projects on GitHub using both of them collectively. And recently, we started using Scarf for analytics just to find out companies that are using our products in production. And we also found out that a couple of Fortune 500 companies are using it in production. Now over to lessons. Like I mentioned, the major challenges for us that we've discovered related to like maintaining open source software is majorly on distributing it and maintaining it, because majority of the code was written like 4 or 5 years ago. The first thing is how we do release management right now. And our release management is currently not like the smoothest, but we've gotten it to a place where it works for us. And it still involves a couple of manual processes, but it works efficiently for how we deploy software currently. We publish releases once a month, and because of that, optimizations don't have like huge effects on our process. So we like to keep things as easy, as simple as possible, and leave a couple of things manual. We use GitHub Actions, and we have a love-hate relationship with GitHub Actions. And we love it because it does most of the heavy lifting for us. What's on the screen is an exact release workflow that we use for the Step CA server, which runs whenever a new tag starting with V is pushed to the repository. This action automates like running CI tests to building and publishing Docker images. And it also leverages existing workflows and manages release versions and handles both regular CI workflow, and then it runs a regular CI workflow on the push code, and if successful, it creates a new GitHub release based on that tag that triggered the workflow. And then something else we use is, we also use GitHub Actions to export Markdown versions of our CLI and push binaries to an S3 bucket for that distribution to customers. But then problem with GitHub Actions is that it has a lot of latency, because changing our workflows and testing them takes about 20 to 40 minutes to see the result of any change. And when we work on a release workflow, it usually involves testing and creating a lot of release candidates. And so the latency is a problem for us. But then something we've done to help manage this latency and GitHub Actions not encouraging local testing is using an SSH debugging action that offers breakpoints and makes the workflow container or VM available on SSH. And this is the tool we use for that. Another tool that we use for releases is Go Releaser because our code base is majorly, it's a Go project, and we love Go Releaser so much that we started to sponsor it because for Go-based projects like ours, Go Releaser simplifies the process of like releasing your Go projects from multiple platforms, and it also ensures a consistent and reliable deployment experience. We also use Go Releaser with GitHub Actions to automate some basics of building and publishing, like creating, creating a GitHub tagged release with release notes, creating change logs and assets. And Go Releaser also creates binary archives for 14 targets for us. It also creates .deb and RPM files for Linux and a couple of Linux distros, and then also creates signatures and checksums for all the assets. And we also use it to create scoop and widget release for Windows. But with all the automations that we have, we still decided to keep a couple of things manual because, like I mentioned, we just realized that for this task, optimization is too much of a big deal for us at the moment. It wouldn't scale for our release candidates, which is like once a month. So we still do some things manually, like building and pushing the open source projects to avoid dependency issues, updating version numbers to our documentation, publishing Helm charts for Kubernetes deployment, and after all that, announcing the new features or updates to our GitHub community and putting it out on our newsletter. So those are all still manual for us, although I'm aware that there are bots that can be used to automate this, but it's just that investment of building out a script to automate this does not make sense for us at the moment. One thing that we currently struggle with, or that we've realized is a big challenge for us right now, is achieving package inclusion in a lot of distros. We have community members always come up with like requests of like new Linux distros to support, and we found that that's a bit challenging. We usually decide which distribution binaries to publish purely casually. If someone mentions it and another community member mentions it and it's mentioned like maybe thrice or 4 times, and then we start considering publishing a binary for that distro. But now packages are still not officially included in major Linux distributions like Debian and Fedora. And that's a long road for us because to confidently sign one of our tools, somebody has to create a source package that builds a binary package for distribution, and then each distro needs to be able to build that package from another source package, and as a result, every Go dependency in our project must have its own source package again, and that's just a really long process. And to do this, we currently do not have, or many of this, what we need does not exist yet. And so for us, something we're actively considering is running our own distribution repositories, our own package repositories, and the tools we're considering are Git here and Fedora Corporation. Given that package inclusion is, a major effort, and we have a large community demanding support for a couple of Linux distros, and we want to make them conveniently available, but that's not currently possible. So we're considering this, and it's a project that we might pick up in the next quarter. Another thing that we've learned also is that date-based versioning makes more sense for a CLI tool for us, because previously we were versioning our releases semantically, and we realized that date-based versioning makes more sense because users want to know what's the age of this package, and date-based versioning conveys that information and signal effort put into the project. For our users, if they are using like a 2-year-old version of the package, they want to know, and semantic versioning does not offer them that information upfront. So we've recently changed our versioning from semantic to date-based versioning. The other side of maintenance that is a problem for us is the people side of maintenance and managing community expectations and feature requests and all of that. And the thing is that software, once written, is never really finished, because it might be feature complete, but in order to continue running, it will still require some ongoing maintenance. And at the very least, this might be like things like keeping dependencies up to date, updating infrastructure to meet demand, fixing bugs or updating documentation. And that's actually the easy part for us, because the harder part is keeping up with user support and adapting to current and constant user need, and all the extracurricular social coordination work that you'd have to accommodate. And for us, once we passed a few thousand users, we noticed that our problem was no longer creating out time from building our commercial products to work on the software, open source software. It was now people submitting all kinds of issues, and in most cases, most of these issues aren't actually issues. They are questions and demands and all of that, and we now had to spend more time working on issues, and it caused a sort of disparity where we were spending more time working on the open source project as regards to our commercial product, and it took a while to find some sort of like balance on how to allocate resources. This is a quote from the creator of Bootstrap. What we found is that the idea of like running open source is idealistic when you open source evangelists will usually say stuff like, oh, it's a collaborative effort, community effort, and all of that. But the reality is that when you start an open source project, you have to make peace with the fact that you are going to be the major contributor to the code, about 95% actually. And this is backed by a research which found that in more than 85% of the open source projects examined by GitHub, less than 5% of developers were responsible for over 95% of code. Another study also found that in a sample of 275 popular GitHub projects across various programming languages, nearly all the contributors only contributed once, save for the original creator. Now, even Wikipedia, the world's biggest online encyclopedia, has a large part of its contribution done by just one person. So that's a consistent pattern. For us, we thought that the presence of like thousands of stars or like thousands of community members would result in like, quality contributions and a community effort over maintaining the project, since we have like a lot of enterprise organizations and big corporations using this project. But that has not been the reality, and our team still writes over 97% of the code. And what we found is that if you're not lucky enough to be employed to work in open source full-time, as is our case, or you're not paid to be part of like an open source program office, you would have to, at some point, you would have to make the decision on how to limit your available attention or be miserable. And so before you accept that piece of code or that contribution, you should be asking yourself if you're willing to bear the burden of maintaining that extra piece of code, because extra contributions actually cost a lot. There's the support angle, there's the security angle, there's the possibility that in the long run is going to introduce some form of instability into your code. And we found that there are two ways of handling this. Some projects decide to do what's called open source, not open contribution, where they totally ignore or state that they will not be accepting any pull requests from external contributors. And they're very upfront about it in their README, and instead encourage contributors to help with things like testing, feedback, documentation, or making tutorials. One example of that is the live stream project. And this is a quote from him where he was like, "I found that accepting and maintaining third-party patches contributed to my burnout and eventual archival of the project. Even small contributions typically required hours of my time to properly test and validate them. However, I've made the decision to keep this project close to contribution for my own mental health and long-term validity of the project." And it's not just the live stream project we found adopting this method. The creator of Lua also has said something similar, where he mentioned how accepting code from like the community was stressful and he was not going down that path. And so this is an option to keep yourself sane, because the reality is that, like it or not, once you start an open source project, unless it's something owned by a big corporation and has like an entire team working on it, the reality is that you might be the only one contributing valuable code to that code base, and every other thing would just be a distraction or something that takes much of your time. But for us, we were interested in keeping a community and trying to grow a community. So this was not a route that we could go. And so we did what I like to call open source, but with controls. So it's open source, but in the middle ground, where contributions are not open to everybody, and you specifically state that there are bandwidths or like gauges around how contributions are accepted. And that's majorly because like the concept of open source started off with good intentions, but along the line it became very exploitative, where there are a few people doing the work that millions of people use, and there's something that people that use open source projects do not actually understand, and is that open source maintainers although it seems like the ethos, it seems like they do, but they don't owe anybody anything, frankly. And if you need support, you either pay for it or go and work on it at your own time. Because I've seen, we're lucky enough that our community is sane, but I've seen cases where open source maintainers are being harassed, like people are paying them to maintain or keep something, and they're being threatened and virtually harassed to the point of a mental breakdown. For us, what operating in the middle ground means is that we do not outrightly ignore pull requests or issues, because that might send like a negative signal to the community. And like I mentioned, we were interested in building a community around our open source projects because of the possibility of it feeding into our commercial projects. And so what we did is that we put some controls around how we work around the open source projects and around how we accept requests from the community. And the first thing for us is to time box the amount of time we spend on it. We have a day in the week dedicated to working on our open source projects. So it's usually on Tuesdays, and everybody on the team gets together, the people that write documentation and all that, and we just go through all the issues and triage it and pick what to work on it for that day, and after that day, it's no more till the next Tuesday. Another thing to do is to make sure that you're clear on the scope and vision of the project. We've severally had people come and request features that are out of scope. They are nice, but like they're out of scope of what the original projects were intended for, and would probably just take a long time. And it's usually people who have these projects, like working on a SaaS or like an enterprise project, and they come like, oh, this will be this, we need this, build this. And we usually just politely encourage them to instead fork the project and write their own features and use it in wherever they want to use it, as we will not be going out of scope of what the project was initially slated for. And when we get contributions or like issues or PR requests that we know that we won't accept, we follow a process of like thanking people for their contribution, explaining that it either does not fit into the scope of the project or it's not up to the standard of code that we accept, and then we offer steps for improvement. And if there are relevant documentation to help, we link to it, and then we close the request immediately. We don't let requests linger if we don't have plans of attending to them, because that letting like issues and pull requests linger for so long adds a sense of like overwhelm to the maintainers and feels like you're not getting anywhere or you're not making progress. And the last thing we do to set some controls and manage the inflows of contributions and regulate our time and mental health is to set very high bars for contributions. So we have a couple of checklists on our issue templates, contribution templates, and stating like what we need you to do and things you must do and understand before you can contribute to the project. And we require that you check this or tick these boxes to indicate if your contribution meets those standards before sending a pull request. And also, there's a bit of nuance for us because our community is a very niche community for people who decide to pick up working on a certificate authority or like a CLI for crypto operations are not in high supply. And we're lucky that those that we get are kind and understanding, and so we don't usually get a lot of spammy contributions and all of that. A resource that we use to set out a couple of issue templates, it's this tool called Taleta. It's a fun, interactive learning resource, not learning resource, it creates issue. I mean, you learn a bit, but then it helps you create issue and request templates based on what you're trying to achieve. So we use that to create some of our templates. And that's how we do open source at Smallstep. A recap. Creation is just the beginning, because while creating open source software is challenging, the real long-term challenge is in distribution and maintenance, and these aspects are often underestimated, but they are very critical for the sustainability of any open source project. And another thing is that open source doesn't mean valuable contributions, because the idealistic vision of open source doesn't always match the reality where it's a collaborative effort. It isn't. And most contributions come from a small group of core developers, with the bulk of users contributing minimally or not at all to it. And another thing, which is the most important thing, is that as an open source maintainer, take care of yourself first, because burnout is real. And especially whenever workload increases due to community demand, setting boundaries and managing expectations will keep you saner for a long time. Thank you. There. Oh, shit. Sorry? Oh, we're 50. Yeah, 49, 50.
How many people are working on the source stuff?
Roughly 5 people. I do documentation. Yeah. So because our product offering is sorry, this seems to be difficult to get out. Sorry. Because our product offering is mainly targeted at like enterprises, so we have a lot of like sales engineers, because that's where we get revenue from, and then we have a couple of like product engineers, but like our core engineers, there are like 4 of them, and then a product manager for the open source project, and then documentation and issue triage and developers.
Project is super important for you.
Yeah, because it feeds into the commercial project, so we tend to give it some sort of priority but at this stage, it's very stable for what the commercial project is based on, but we try to like maintain a balance between what the community is asking for and something if building like into a commercial project. We haven't had to build any new feature for our open source projects. Regarding our commercial projects in the last 3 years, it's usually just to make sure that we have a thriving community around the open source project, which might eventually feed into
And all the other stuff that it's compatible with your work. Operating systems and maybe architectures and stuff like that.
yeah. Thank you.
Great time here.
Yeah,
I
thanks.
cannot help you with what's great here. I'm not from Denmark either.
Oh, yeah, I got in yesterday and I don't know, I'm trying to,